In this video presentation, we'll be looking at the feasibility study sponsored by the NICE program, and the feasibility study focuses on sustainable infrastructure and construction repair using calcium carbonate waste lime. The project is actually a collaboration among several partners, Scottish Sailfish, British Egg Industry Castle, Just Eggs, Envirosol, which is a lime contractor, and Leeds City Council representing an asset owner authority, and also in a collaboration with the Instituto Politécnico de Tomar, which is a Portuguese university, along with the University of Leeds. So basically, the motivation for the study is that currently, because of the extreme climate patterns that arise from climate change, those are causing a lot of performance shortfalls in our infrastructure. And notably here in the slide, we have a few examples on transport infrastructure, loss of performance. And typically, one of the ways to mitigate these performance shortfalls due to climate change is basically to improve the soil, and lime stabilization is one of those that are typically implemented. And the reason for that is because it increases soil strength, reduces susceptibility to volume change that could arise from seasonal moisture changes that could result from infiltration and drying or droughts in the summer. And also, in addition to that, allows the reuse of marginal soils that would be otherwise classified as excavation waste. So it also motivates or contributes to more sustainable practices. So basically, the motivation for this feasibility study, so reusing calcium carbonate waste, is because currently the production of lime relies heavily on the use of quarried limestone or chalk as a source material. And obviously this is undesirable because it leads to abiotic depletion, and the quarrying of those materials have inherent environmental impacts. And those, among some of the most important ones, are carbon emissions, the use of energy, land use, and also because it could destroy unique karst habitats. So one solution is, like I mentioned, is to use calcium carbonate waste. And those are mainly arising. So in these studies, we focus on the use of eggshells and seashells. And just to give, and those would be ideal materials because of their composition to be a replacement for a lime source material as a raw material in the lime production. And there's actually substantial production, around 19 kilotons of eggshells and 5 kilotons of seashells in the UK, that could meet the market share demands used for soil stabilization. And in addition, these materials are ideal for soil stabilization because the lime purity requirements for this application are not as stringent as for other applications. So in a sense, it's a good solution for this type of waste. So basically, the feasibility study has 5 different work packages. In the first one, we're focusing on the testing protocols for the calcium carbonate waste lime, and also evaluate any purity issues and their associated impact on the performance of the material, and also evaluate what will be volume requirements for other pathways for reuse. In the second work package will be devoted to evaluate the improvement in performance of soil stabilized with this type of calcium carbonate waste lime. And for that, we'll be looking at small strain stiffness behavior. So that's a measure of shear strength in the soil. As the material is going to be subjected to wetting and drying as a result of infiltration due to rainfall and drying over the summer in a period of drought, it is also very important to look at the water retention behavior and permanence of the lime in the soil. And for that, we'll be devoting the work package 3. Because this is about reusing a waste and basically linking two different circular economy sector loops, meaning that we are linking the food industry loop with the production of eggshells and seashells with the construction materials loop by using those materials as raw materials for the production of lime. It is important to conduct a life cycle assessment, not only for soil stabilization, but also other potential pathways, such as ceramic applications. And we'll be doing this in the work package 4. Finally, as it is very important to make sure that there's an optimal technology transfer into the industry to make sure that these wastes are used more widely in the construction sector, it is very important to engage both industry and government sectors to make sure that this type of waste in this type of application is regulated. And for that, we have work package 5 devoted to doing that. And the industry partners that are involved in the project will assist in doing so, as well as the network of the Circular Economy Hub. Finally, these are some of the deliverables that are going to be that will arise from the feasibility study. First, there will be an opportunity to develop optimal calcium carbonate waste lime manufacturing protocols that could be then scaled up to use in a real lime manufacturing plant. We also want to establish what are the performance of this type of waste lime compared to the more standard calcitic lime that is manufactured based on limestone and chalk. And also, it is important that if you are using a different type of lime, that we developed quality control benchmarks for use during construction, because there's a real appetite for the use of these materials in construction sites at the moment. The other deliverable, which also will enhance its use in construction applications, is the life cycle assessment for soil stabilization and other application pathways. Will strengthen the motivation for using these materials and will clearly highlight the savings in terms of carbon and also landfill fees in relation to we can reuse a waste material that would be otherwise landfilled. Also, they will have scholarly publications, including conference papers, research updates, and policy briefs that will arise from the findings of the feasibility study. And obviously at the end, because this is a feasibility study, the idea is that we'll build on the findings that we established in this small study to scale up to future funding applications, and in particularly for scaling up for a real case in a construction site where we can actually monitor real time and real scale the performance of this type of lime. Thank you.